Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help ISU Actuary. I will present a problem for exam IFM today, and soon, I hope within about 10 days, I should have a study manual ready for exam IFM, which will be available at smarturl.it/btdt-IFM. Here's a problem for today, for exam IFM. You are given the following information about a portfolio with 4 assets. There are assets 1, 2, 3, 4. Market value of asset 1 is 40,000, asset 2 20,000, asset 3 10,000, asset 4 30,000. And covariance of assets return with the portfolio return is 0.15 for asset 1, negative 0.10 for asset 2, 0.20 for asset 3, and negative 0.05 for asset 4. Calculate the standard deviation of the portfolio return. And let's write RP for the portfolio return, a random variable. And if the portfolio consists of assets with returns Ri, random returns with I equal 1 through n, it's a general case here right now. It's not only this problem, but the general case. So not just 4 assets, but any number n. With allocations to them of x1 through xn, then the return of a portfolio is a weighted average of the returns of individual assets. So it's the sum of xi times Ri, so that the variance of Rp is the variance of this weighted sum of xi Ri. And the formula that you should have learned from probability says then that's just a double summation thing with I running from 1 to n and j running from 1 to n of xi times xj times the covariance of Ri and Rj. And of course, when I is equal to j, that covariance becomes a variance. And then what we do here is we take that part with j equal to 1 to n and use the property covariance is a linear operator to move the covariance in front of this. Now, of course, xi does not depend on j, so we can just move it in front immediately because it's a constant. And then after that, covariance, it's a sum of covariances. So it's a covariance of a sum in the second variable. The first variable, Ri, of course, doesn't depend on j. But covariance is a linear operator. That's what we're using here. So linear operator in each of its variables. So this covariance of a weighted sum is weighted sum of covariance. It's actually the other way around. It's the way it's written is that the weighted sum of covariances is a covariance of a weighted sum because of it being a linear operator. And what we see here is that this becomes the sum from I equal 1 to n of xi times covariance of Ri with the sum from I equal 1 to n of xj Rj. And this sum of xj Rj is simply the return of the portfolio, so this becomes the sum from I equal 1 to n of xi times covariance of Ri with Rp. And the point of all this, I'm deriving this formula, but actually in the textbook that's given. You are supposed to memorize this formula. This is an actuarial exam. You memorize things because you have about 5 minutes per problem. And you should know it for the test. So as I said, this formula is actually given in the textbook. And you should remember it. Now note that the total value of the portfolio in this problem is 100,000. So allocations to individual assets are 40% in asset 1, 20% in asset 2, 10% in asset 3, and 30% in asset 4. So, in this case, the variance of portfolio is this weighted average of the covariances of individual assets with the returns of individual assets with return of portfolio. So it's 40% times 0.15 plus 20% times negative 0.10 plus 10% times 0.20 plus 30% times negative 0.05. And that's 0.045. That's the variance, and the standard deviation is the square root of that, approximately 0.212132, and that's answer D. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.